forms of work, right? Here different forms of work are there. First is a electrical work, right? Electrical work, here W equals to VI, right? So its unit is watt, right? Or 1 unit is equals to 1 kilowatt hour, right? This is the unit of energy, right? So second is the mechanical work. Mechanical work means the energy transferred by a force acting through a distance, right? So there are different types of mechanical work, right? Number one is the gravitational work. Gravitational work means the work done to move an object against the force of the gravity, right? One and put at a point 2, this is the H2 from the ground, right? So the work done against this gravity, so W equals to mg H2 minus H1, right? And B is the shaft work. Shaft work means as we know, shaft work W equals to torque into the angular velocity, right? Angular velocity is a 2 pi n, so I am writing it 2 pi n. This is the value of omega, right, into torque, right? So we can calculate the shaft work, right? This is also power, means the rate of work done, right? Third is the, right? So F is the, we can write is a F equal to minus kx. So from state 1 to 2, if we integrate it, so we will get k into x2 k into x2 square minus x1 square, right? Is the boundary work, or this is also called displacement work, right? So the work involved in moving the boundary of the space containing a gas, right? Here for example, here we have the piston cylinder, right? So this is the initial state when system will do some work, so final, this is the state 2, right? So here if we as we know, work is the F into dx, right? So F, and we also know pressure equals to F upon A. So from here F equals to P into A, right? We put this value in place of F, P into A, right, into dx. So A into dx, so this becomes the volume, right? This is the dx, A is the cross sectional area of this piston cylinder, this piston. So from here we will get this dV. This is the volume, small amount of volume, right? Volume. And from here we know this is P is the function of volume, right? So there are number of processes are there, right? First one is the equation, isothermal process, right? As its name indicate, isothermal means same temperature. Temperature is constant. Temperature is constant during the process, right? So here for example process 1, here state 1 to state 2, in this process temperature remain constant, right? From here if we see, this is PV equals to MRT, equation of state. This is called equation of state. Here M is a mass. Mass we take the constant, for example 1 kg, right? R and T, right? T is a constant, right? For a given gas, R is also constant. So it means PV equals to constant for a isothermal process, for an isothermal process. This value is constant, PV equals to C. So if from here value of P we put here, we know the work done into P into delta P for any process 1 to 2. Here So if we put this value, so we will get C upon V, right? So from here, if we integrate this one, so C is the constant, so it will come outside. So here del V upon V. So here we know when we integrate, so we will get the ln V, right? So integrate 1 to 2, so here we will get ln V2 upon V1. But here C is a constant. So state 1, here its value is P1 V1, at state 2 its value P2 V2. So we can put any value, right? Here we can put P1 V1 or P2 V2 also, right? It is the according to the problem, right? So here work done, this is the work done, right? Third one, second is the isobaric process. Baric means here is the pressure, right? If pressure is constant, such process is called isobaric process. Pressure is constant throughout the process, right? So here, for example, here PV diagram, here state 1 to state 2, pressure is constant in this process, right? So here pressure is constant, so we know the work done equals to P into delta V. So anything is that is constant, it will come out. So P is a constant, so it will come out. So we will integrate V. So V, here V vary from V2 to V1 to V2, right? So work done is W equals to P V2 minus V1, right? Third one is the isochoric. Isochoric means volume constant during the process, right? So here, for example, here piston cylinder is there, but volume is constant. So we fix this volume and putting some heat, something. So this will not move. So if it will not move, so work done during this process, right? There is a change in volume. There, this is 0, right? So work done is 0, right? During the isochoric process, right? Next is the plytropic process. Plytropic process means here PV to power gamma equals to n equals to constant, right? So work done formula is same for a bond displacement work, right? So this is the same for all, right? Formula this is same for all, but this for this process here we put the pressure equals to C upon here C upon V to the power n, right? So C is the constant, right? This C is a constant, right? So this is constant, so this will come out aside from the integration. So only this term is there, right? As we know the formula, here we will get this one and then integrate it, so we will get this one, and we can multiply C here. So here C into V2 1 minus n, and here C into V1 1 minus n, right? And divided by 1 minus n, right? So when we so here C is the constant, P1 V1 to the power n for state 1, right? And for state 2 so P2 V2 to the power n, right? So here in the first case we are writing here it a V2 because here V2 is there, so we are writing P2 V2 to the power n, and here this is the V1, so we are writing in place of C in terms of V1 and P1, right? Because we doing some manipulation, right? So when we manipulate it in such, will add and these will cancel out, so we will come out with this formula, right?